Okay, this is an introduction to binary. Alright, the reason why I'm going over this is because this is going to be a series into subnetting, but before you can do subnetting, you have to understand binary. So let's go. Alright, binary is a numbering system, not unlike decimal, which is the numbering system that you've been counting in probably your whole life. But binary is a numbering system where there's only two valid digits, 0 and 1. Alright, decimal, which is a numbering system that you're probably familiar with, has 10 valid digits. The first digit is actually 0, and the 10th digit is actually 9. And we can enumerate all of these. So you got 1, 2, 3, 4, 5, 6, 7, 8, and of course 9 is the 10th digit. This is important, especially as you move forward in your networking career, because oftentimes on a router, your first port is actually port 0, right? In programming, right, we count with 0. That's what you start with, not 1. So many buffer overruns are caused because people start counting by 1, not 0. Alright, so this is important to understand. There's 10 digits. Alright, there's actually there's many different numbering systems. Another popular one is hexadecimal. And there, you go from 0 to 9, but we have no way to express 10 as a single digit, so what we say there is alpha. Alpha is 10. Bravo is 11. Charlie is 12. Delta is 13. Echo is 14. And the 16th digit is Foxtrot. Alright, here we're just going to primarily focus on binary and decimal. Let me get rid of this purple. Let's go to black. Alright. Now, before we talk about binary, it's let's just review how we count, right? So, let's say you have a normal number, 2 digits. Alright, remember, this is your ones column, which is 10 to the 0 power. This digit represents 10 to the first power. This represents 10 squared. This represents 10 cubes. Alright. Even though we use the same digits or the same symbols in each digit placeholder, they mean different things. So for example, if I have the number 5, 5, 5, 5, right? We know that this 5 is different than this 5. Alright, so let's continue here. So let's write a simple number like 6, 7, 8, 9. What is this number? Alright, well, we could enumerate them out. We'll do that. This is 10 to the 0, or ones column. 10 to the first, or the tens column. 10 squared, or the hundreds column. And 10 cubed, which is a thousands place. So we have 6 1,000s, or 6,000, plus 7 100s, or 700. And I don't know why I put a comma there. It's kind of crazy. Let's get rid of that. We have 8 tens, or 80. and we have 9 ones, which is 9. We add that all up, and we get 6,789. Now I know. Why did I do all of that, right? We did that so that way, when I show you binary and alright, so binary we have the same thing, and I'll just draw out a couple digit values here. So binary is base 2. So it's going to be 2 to the 0 power, 2 to the first power, 2 squared, 2 cubed. And you can go on and on and on, right? 2 to the 4th, 2 to the 5th. We'll stop there. Remember, that's very similar to what we did here, except for decimal, and I didn't say this explicitly, so I'll say it now. Decimal is base, what? You got it, 10. So let's come over here. Alright, if we were to write the decimal equivalent of each one of these numbers, this would represent your ones column. This is your twos. 2 squared is 4. 4 times 2, or 2 cubed, is 8. 2 to the 4th, 16. And 32. If you see a pattern here, it's because that's by design. What do you think the next digit would represent? 64. 2 to the 6th, which is 64. How about the next one? 2 to the 7th. 128. You got it. Now remember here, there's actually 8 places. 0 is the first, 7th is the 8th. Alright, so let's go here. Hey, what's up, man? No, that's alright. Yeah, everything's good. Alright, yep. Alright, so just so we don't confuse you here, though, I won't write the base number with the exponent. I'll just write the decimal equivalent. We'll keep it here for now. And remember, in binary, there's only 2 valid digits, 0 and 1. Alright, so let's write a number 1, 0, 0, 1. And we want to know, what is this number in decimal? Well, lucky for us, we have the decimal equivalent down here. Let me highlight these just in case you forget. So here's the decimal equivalents. Alright. And I'm also going to say, if you have a 1, we're going to say count it. And if you have 0, we're going to say don't count it. Fair enough? So 1 means count it. 0 means don't count it. So over the 8 column we have a 1, so we're going to count it. So we'll add 8 here. We'll call this the stack. Over the 4's columns we have a 0, so we're going to skip it. 2's columns, 0, so we're going to skip it. 1's column, we do have a 1 there, so we're going to count it. So this number is equal to 9 in the decimal world. So in binary, it's 1001. In decimal, it's 9. Alright. Now we can go, let's do a couple more. Let's see, I don't know, let's do the number. What I want you to recognize here too is that in order to write the number 9 in binary, it's going to take you 1, 2, 3, 4 bits. 4 bits to write the number 9. Alright, that's going to be very important later on, especially when you're trying to come up with your subnets. But let's do another number here. So let's do, we'll get rid of this. And we'll get rid of, we'll clear our stack. Yeah, well, let's write the number 101101111. Let's see what this number is going to be. So we got 128 plus 32. Add that up, that's 160, right? 160 plus 16, 176. 176 plus 4. It's going to be 180. Let's carry 180 over here. 180 plus 2. 182 plus 1. 183. You can pretty much always bet that if your last bit is a 1, then your number is going to be odd. Alright? That's kind of a way for you to check this. If you're going to take any kind of certification, you're going to have to do these conversions very quickly. Alright, you know what? Let's do something fun. Let's try to go in reverse. And I'll show you how to do this. It's pretty easy. Let's try to write the number 100. And I can see them like this. Let's open up a new page here. And we want to write the number 100. And let's come over here. We'll write our, you know what, let's do it like this. Wow, that's sloppy. Let's do it like this. You know what? Let's write it neat so that way, if anything, we can use this over and over again. Let's do a square. Okay. And we'll kind of split that square down the middle. And we'll do 128. Oops. I'll be at the top. '64. 32. 16. 8. 4. 2 and 1. So we'll say 1, 2, 4, 8, 16, 32, 64, and 128. And we want the number 100. So the way you do this is, there's 100. Can 128 go into 100? No. So we'll say, remember we said over here, let's write it at the top here, 1 means yes, and 0 means no. So can 128 go into 100? No. How about 64? Yes. We'll add it to the stack, and then we'll subtract it. 36, right? Get 32 go into 36. Yes. 32. Decrement it from the stack. We get 4. Can 16 go into 4? No. How about 8? No. Can 4 go into 4? Yes. Subtract 4. Get 0. Now, since we have nothing left, we finish it out. So in order to write 100 in binary, it's going to be 1, 1, 0, 0, 1, 0, 0. Alright. You could write 0 here if you wanted to keep it all 8 bits. But just like in your normal life, if I asked you to write the number 500, you'd write it 500. Right? You wouldn't write 0, 500. You could. They both mean the same thing. But this is kind of silly putting that leading 0 there. So, alright, you want to do another one? Let's do another one. Okay. Let's get a sec. Alright, let's do the number. What should we do? Let's do 200. Can 128 go into 200? Yes. And we subtract that to 110. Borrow 9, 1. So we get 7, 2. Can 64 go into 72? Yes. 64. See, kids? Math does help you out. 6, 1, 8. Can 32 go into 8? No. How about 16? No. How about 8? Yes. Got nothing left. So, how do you write 200 in binary? 1, 1, 0, 0, 1, 0, 0, 0. Notice here that we need 1, 2, 3, 4, 5, 6, 7, 8. We need 8 binary digits in order to write the number 200. This is the decimal. This is it in binary. Alright, so I showed you how to convert from binary to decimal, and we converted decimal to binary. The last thing I want to do is, here we are purposely used only 8 bits. So I'm wondering, what would be the largest number that we could write in binary with only 8 bits? That's easy. Just turn all 8 bits on. Okay, let's do that. So if we turn all 8 bits on, probably should have left that at 1. 1, 2, 3, boom, boom, boom. That's what it looks like. 1, 2, 3, 4, 5, 6, 7, 8. But I wonder what that equals in decimal. Let's figure it out. So we got 128 plus 64. 8 and 4 is 12. Carry the 1. 6 and 2 is 8. Plus 1 is 9. Drop down to 1, 192. Let's add 32 to that. And we're going to get 4. 9 and 3 is 12. Carry the 1. It's 224. We'll add 16 to that. Right? 6 and 4 is 10. Carry the 1. 2, 1 and 1 is 4. Drop down to 2, 240. Let's add 8 to that. 248. Let's add 4 to that. 252. Let's add 2 to that. 254. Let's add 1 to that. 255. So we know the maximum number that we can write with only 8 bits is 255. Okay, what would be the smallest number we could write? Be all zeros, right? All the bits turned off. 0. So with only 8 bits, you can only write a decimal number in the range of 0 to 255. That's important to know, right? Because, as we'll see, an IP address, or specifically an IPv4 address, it comes in the form of these so-called dotted decimal numbers, right? But each one of these numbers is called an octet. And the reason why they're called an octet is because they're equivalent to 8 bits. So in order to have a valid IP address, right, your numbers have to be between 0 and 255. So remember I said each one of these numbers is called an octet, which is 8 bits. And if you have 4 octets, each one being 8 bits, 8 times 4 is 32, or 32 bits. Alright. Now, I wonder what, if you have 32 bits on, I'm not even going to enumerate it here, but you'll just have to trust me on it. In statistics, and I even forget the, I don't know if there is a rule, but if you want to figure out how many permutations you can have with anything, like say you have blue, red, green, blue marbles, right? And you have 3 marbles that you can pull out. How many different combinations of marbles in a specific order can you have? That's called a permutation. All right. The way you do that is, what are the chances for each to pull out? So you have 3 different possibilities, and then you multiply that. Actually, so the possibilities raised to the power of how many digits you have, which is 3. All right. In our case, we're talking about binary here, so a bit can be either a 1 or a 0, so it's going to be 2 different possibilities, and we have 32 places. Alright, well, if we do the math on that, let me see if I can pull a calculator up for you. Okay, mouse, come on. Come back to life. We'll go on scientific mode. 2 to the 32 power. That is 4 billion. But we do it like that. That's your. So how many different IPs can we have? We could have 4,294,967,296 different IPs. Sounds like a lot, and it is. But you'll learn that we're actually running out of IPs. So they say we'll be going IPv6. I personally have a problem with IPv6, but we'll talk about that another time. All right. I told you guys about another numbering system, which is hex. Let's just do some hex just for fun and some pain, right? Just to show you that you can convert from one to the other. So hexadecimal. We said that in hex you have digits 0 through 9, but you also have alpha through foxtrot. This is important, if not only to understand that your MAC addresses, which is your layer 2 address, is in the hexadecimal format. And sometimes on your equipment it's really difficult to see. So you might see something like 00:1 foxtrot, and you're not sure whether or not this is a 0 or an O. Well, it's a 0 because O is not valid in hex. Alright, let's do some conversions. Just making sure I'm not on mute here. I want to write the number 100, which is in decimal. I want to write that in hex. Alright, so the way you would do this is, in hex you have the ones column, then you have the 16s column, then you have the 256 column. How did I get that, by the way? Well, remember this is 16 to the 0, 16 to the first, 16 squared. 16 times 16 is equal to 256. And if you multiply that by 16 again, 4096. So we won't go any higher than that. 4096. So let's write the number 100. Well, can 256 go into 100? No. How about 16? Yes, it can, but how many times? Well, we know that 16 times 5, I believe, is 80. Let's check that. 16 times 5 is 30. 0 carry 3. 5 times 1 is 5 plus 3 is 8. 80. Alright, and if we add another 16 to that, we'll be at 96. That gets us close. Alright, so we'll say 6. So we have 6 16s. And if you subtract that from 100, that leaves us with 4. Well, then we just need 4 ones. So the way you write 100 in hex is 64. In decimal, it's 100. And in binary, it's 0, 1, 1, 0, 0, 1, 0, 0. If I did that on the fly. That's 128 plus 64. 64, so we put that on, plus 32. That gives us 96. So all we need is 4. So we'll skip 16, 8, 4, we count it. That gives us 100, 2, 1. So these are all equivalent. This is hex, this is decimal, and this is binary. And let's check it just to make sure we can see if I'm right here. So we'll go over here, we'll go into programmer mode, and notice that we have decimal selected. We'll write the number 100. Notice here in hex it's 64, in octal it's 144, and in binary it is 0, 1, 1, 0, 0, 1, 0, 0. Alright, practice this. Make sure you got it in and out. When you do, come back and we'll get into some subnetting. Thanks for watching.